Hey everybody, welcome to Astronomy. I'm going to try to make this quick today. It's a Friday. I know I don't always post lecture videos on Friday. I'm also going to post a quick lab later on today. But we got 1 week left next week, and I want to make sure we get to cosmology and the Big Bang. So in order to do that, I want to do a quick lecture about galaxies today and how we know, just historically, that we are in a galaxy that is one galaxy of many, because it's kind of an interesting story. When you look out in the sky at night, you see this stripe of light that goes from horizon to horizon that we have called, since the time of ancient Greece, or many cultures have called some version of the Milky Way, because this white band of diffuse light that crosses the sky. This is a photograph of the Milky Way taken with a modern telescope, and you can see that it is a bunch of stars. We didn't really know that it was a bunch of stars until Galileo in the 1600s pointed his telescope at the Milky Way and showed that diffuse. Can you hear me? I just realized that my microphone was really far away from me during all of that. Sorry, I probably sounded like I was speaking from down the street. We didn't know until the 1600s, when Galileo pointed his telescope to the Milky Way, that diffuse band of light was made up of individual little stars. But because we are in the Milky Way galaxy, we see that diffuse band of stars all the way around us. If you go to the southern hemisphere, you see this. You still see this stripe that goes around the sky. In the 1700s, William Herschel, it's also the dude who discovered Uranus, tried to map out as best as he could, kind of guessing the distances to stars from their brightness, which is not a very good way to guess, and we didn't have any ability to do much better in the 1700s. But since we see the Milky Way when we look in all directions, he assumed that we were in the middle of it. This is Herschel's map here. It shows us in the center of this blob of stars, thicker in this direction. That's why it looks like a stripe when we look around us, because there's more stars in the sort of horizontal direction in the stripe than there are in the vertical direction. This split here in the Milky Way is this dark region where Herschel drew fewer stars. We see fewer stars there because of that split. That's actually not what's happening. The split is actually dark gas and dust that's blocking our view of the stars behind it. It's not a place where there are no stars. So this is a map that Herschel tried to make in 1760. What Herschel did not realize was that there are way more stars than we could see with our telescope in the 1760s, and that we are not in the center of this grouping of stars. We are way out on the edge. And the reason we can't see all of the stars in the galaxy is our view is blocked by the stuff in the galaxy, because we're inside it. Taking a picture of our own galaxy would be like trying to take a picture of the crowd at a concert when you're in the middle of the crowd. All you can do is turn around and take a picture of the people around you. You can't get a picture of what that whole stadium or concert venue filled with people looks like. So you've never seen a picture of the Milky Way galaxy from the outside. You've seen pictures of other galaxies from the outside. You've seen artist conceptions of what we think the Milky Way looks like from the outside, but you've never seen the Milky Way from the outside, because we've never been outside the Milky Way to take a picture of it. We would have to go tens of thousands of light years to get outside the Milky Way. How do we know that the Milky Way has this shape? How do we know that we're not in the center of it if we can't see the other side of the Milky Way because of all the junk in the way? It is because we have nowadays other kinds of telescopes besides just visible light telescopes like they had in the 1700s. For example, we can use a radio telescope to see through the gas and dust that blocks our view in the galaxy, to map the other side of the galaxy over here and know that we are in fact not in the center. We are way off near the edge. We also talked about the fact in class that there are these things called nebula. Nebula just means cloud. There are nebulas where stars are forming. There are nebulas that are the leftover debris from a star blowing up. And in the late 1700s, early 1800s, we discovered these things called spiral nebulae. They look like a little spiral, like a little whirlpool of light through our best telescopes at the time. And we see them in all different directions when we look in the sky. There was a debate, a literal, I mean, a figurative debate, but eventually a literal debate about what these spiral nebula were. Option one was that they are just little spiraling clouds of gas in our galaxy. They are part of our galaxy, and the reason they're spiraling is because sort of gravity is pulling stuff into the center or something like that. The other idea was that these spiral nebula were galaxies like our Milky Way, but very, very, very far away. The antiquated term that was used for these things was island universes. That's a terrible, terrible term because the universe is everything. There's only one universe. But before we had used the word galaxy to refer to these separate galaxies, they were sometimes called island universes. So in the, let's say, late 1800s to early 20th, early 20th century, early 1900s, there were two competing views. The spiral nebulas were just little spiral gas clouds in our galaxy, or the spiral nebulae were very, very distant, essentially copies of the Milky Way, that we were not the only galaxy. Notice the difference in scale of the universe in these two pictures. In the spiral nebula version, the Milky Way galaxy is essentially the only thing in the universe. The size of the universe is the size of the Milky Way galaxy, about 100,000 light years, let's say. In this picture, because they are so dim, they must be very, very far away because they are made of billions of stars like the Milky Way galaxy. If they appear dim, they must be very, very far away. So this version of the universe is millions of times bigger than this version of the universe. In order to accept that the spiral nebula are galaxies like the Milky Way, you have to put them very, very far away. So suddenly the mental picture you have of the universe you live in has just gotten millions of times bigger. The actual debate that happened, the Shapley-Curtis debate, was held in 1920. I mentioned the fact that I always find it remarkable that we have not known about nuclear fusion and what makes the sun hot for barely 100 years. Likewise, we have not known that the Milky Way galaxy was not the only galaxy for barely 100 years. The debate was held at the Smithsonian, right a couple hours north of here, between Harlow Shapley and Heber Curtis. I always forget, Heber Curtis was actually a UVA alum. Shapley believed that the distant nebula were small gas clouds in our own galaxy, and Curtis said that these were actually essentially things like the Milky Way, spirals of billions of stars located millions of light years away. So they were big and distant. The reason you could have a debate about this in 1920 is that there was no conclusive evidence. You don't debate about things what there's conclusive evidence about. You debate about things that are open questions. The reason there was no conclusive evidence is in 1920, all we had was big telescopes that you could look through with your eyeball and sketch what you saw. We did not have, or we just barely had, photography. Once we developed photography, you could take a long exposure of a galaxy rather than just looking through it with your eyeball and see it instantaneously. You could point a telescope at one of these objects and take a photograph that took a half an hour or an hour or 6 hours and gradually accumulated that light to get a clearer and clearer and clearer picture of what you were looking at. So astronomical photography settled this debate once and for all. The person who did that, the person who first photographed another galaxy and saw the stars in it, was Edwin Hubble. That's why we named that big space telescope after him in the 90s. So after, that was about 1924, 25, 26. By 1930 or so, we had established that, yeah, these little spiral nebulas are not just little gas clouds in our galaxy. They are made of billions of stars, which means they must be millions of times further away than we thought. Many of the spiral nebula have a similar structure to the Milky Way. Milky Ways consist of 200, 300, 400 billion stars. We don't have a very accurate estimate of the number of stars in the Milky Way. Why? Because we can only see the stars around us, and we can't see the stars on the other side. So we can't count them all. All we have is estimates. The central bulge is where most of the stars are located, but we are located in the spiral arms of the galaxy. The spiral arms of the galaxy are also filled with a lot of dust and gas, and it's this dust and gas out of which new stars and new planetary systems are constantly forming. Our Milky Way galaxy is a little less than 100,000 light years across from one side to the other. Just like our solar system doesn't have a hard edge, the Milky Way doesn't have a hard edge either. There's stuff orbiting the Milky Way out in the outskirts. So you can't just draw a line and say, all right, this is the end of the Milky Way. But give or take, I just, in my head, I just store the number 100,000 light years because it's easy to remember. So a little less than 100,000 years. The central bulge is about a fifth of that, maybe 20,000 light years in diameter, not radius. And our sun is located about 2/3 to 3/4 of the way out from the center towards the edge of one of the spiral arms. Everything in a galaxy is orbiting the mutual mass and gravitational pull of everything else in the galaxy. So every star in the galaxy is moving in an orbit around all the other mass that's closer to the center. Our sun orbits the center of the Milky Way galaxy, and one orbit around the center takes about 250 million years. What was going on Earth 250 million years ago? That was before there were dinosaurs, so far ago. So the location of the sun's about like 25,000 light years, let's say, which is about half the way from the center to the edge, depending on what you want to call the edge. So one orbit ago of our solar system around the center of the Milky Way was before the dinosaurs. 2 orbits ago was just before animals and plants had colonized the land. So the sun has only made 2 orbits around the Milky Way galaxy since life left the oceans. And it has only made 16 orbits around the center of the Milky Way galaxy since the Earth formed and solidified. So you can think of a galactic year as being about 225 to 250 million years, and our solar system is only about 16 galactic years old. Just like our solar system has a bunch of junk that orbits it way out in the outskirts, the Oort cloud and the Kuiper belt, the galaxy has a bunch of stuff that orbits it way out in the outskirts, gas and dust, stars on really, really eccentric orbits, like comets are in really eccentric orbits in our solar system. So the stars that we see in these bright photographs are the stars that are concentrated to the center, but there's stuff out there on the edges as well. I'm not going to get into the differential rotation and all this business. I think I'm going to stop for a second right there and see what else we need to talk about. I'm not going to talk about that. I'm not going to talk about that. I'm not going to talk about that. Yeah. I think I might stop.